and numbers might have changed a little bit on the videos, but the content didn't. These are the finding intercepts notes. So the first thing we want to talk about is what are the X and Y intercepts. So we've definitely covered the Y intercept tremendously, okay? But let's talk about what both intercepts are. An x-intercept is the X value where the graph crosses the X-axis, okay? In other words, it is the value of X when your Y value equals 0. And it'll be written in the form of X, 0. The really, really important thing about x-intercepts is what they are also called, and that is very, very important. They are also called the roots, the zeros, and the solutions. Okay? So this is really, really important, especially roots and zeros. Zeros are where it crosses the x-axis, okay, whenever a question asks you that. The y-intercept we have covered extensively. The y-intercept is the y value which the graph crosses the y-axis. That's your straight up and down axis. That's the b value in y equals mx plus b. Okay, it's where we begin on the y-axis. It is the value of y when x equals 0 because we haven't moved up or down on the graph. And it will be written in the form of 0, y. So these are our two intercepts. So let's go down here and let's mark them now. Clearly, this right here, where it crosses the y-axis, is the y-intercept. We also denote it as a lowercase b. The one where it crosses the x-axis is the x-intercept. And again, I'm going to have y'all write this, and y'all will write this a lot. It's also called the zeros, the roots, the solution. I'm sorry, it's singular. It's not plural. It's only one of them, okay? It's plural when we cover something else later, okay? So that's just really, really, really important to note, especially these other names right here. These are the keys right here. This is how you will be asked it a lot. So then we have intercepts from a graph. The x-intercept, okay, is where the line crosses the x-axis. The y-intercept is where it crosses the y-axis. So what it's going to ask us to do is write them. So I'm going to look at the x-intercept first because that's what's written up here first. So it'll be denoted in blue. And here is your origin. And my x-intercept where it crosses the x-axis is -2. So a point is written x, y, so that would be -2, 0. The y-intercept is where it crosses the y-axis, and that would be right down here. And that is 1, 2, 3, 4, 5, 6. That would be 0, -6. That is all you have to do is look on the graph. You just have to be sure you remember that the y-axis is the up and down. Remember, throw your arm up in the air. That's where we plot that y-intercept at. On the next one, our x-intercept, okay, is where it crosses the x-axis, which we're just going to pretend it's that exact. 1, 2, 3, 4. So that's going to be at -4, 0. -4, 0. And something I didn't do on the other one is you can go on ahead and point to it so you know what you're looking at exactly. The y-intercept is right here, okay, and it's where the graph crosses the y-axis, which happens to be at 2. 0, 2. Remember, a point is x, y, sideways, then up and down. Those are really the easiest ones to identify. They're super easy, and these are the ones that usually show up on tests. The third part, and there's 4 parts, so we're almost done, is intercepts from a table. Now, this is kind of the exception. To me, that these are a little bit more confusing to identify, and I usually don't see them, okay? So what you're going to do is you're going to look down for the x-intercept. So I'm coding this one in blue as I have been. For the x-intercept, okay, you're going to look down the y column until you see 0. Then you look to the left to see the x value because the x-intercept is a number, 0. So let's go identify the x-intercepts on both of these. You go down the y column first, where y equals 0, and there is your x-intercept. It's even written as a point, 2, 0. On this one, again, you're looking for where the y equals 0 because that means you haven't moved up or down on the graph yet. That means you just moved sideways, and there it is right there. So on the opposite end, the y-intercept is you look down the x column to where you see 0, look to the right, and that is your y-intercept. It's where x equals 0 because you haven't moved sideways on the graph. So let's look over here where x equals 0. So I'm going to go down here, and I see x equals 0, so there is my y-intercept. And it's written as a point, as an x comma y. It's already written that way. So on number 4, let's do the same thing. This is where x is 0. It's at 10. 0, 10. And that is it. I don't always see those on the graph. Those are difficult ones for me, and I usually use regression, which we're going to talk about later, just because I don't see it all the time. So it's definitely something to look for. When you see a 0 on a table, it means it's an intercept of some sort. And the last example. These are the ones that take a little bit longer to do, okay? They're a little bit more work, all right? And generally I have my notes in front of me when I'm working on them. So let's look at the x-intercept when y equals 0. So what you do is you plug a 0 into the equation for y and solve for x. That's it. You plug a 0 into the equation and solve for x. So we're going to do these top two up here. And what I tend to do is when you plug in a 0, that 6 times 0 becomes 0. So I just tend to cross it out. And I'm left with 3x equals 12, if y'all see that, because 6 times 0 is 0. I just get rid of it. Now, for the 3 and the x, when a number and a letter are right next to each other, they are multiplying. How do we get rid of multiply? We divide. So x equals 4, which means a point is x comma y. And if you'll see right up here, it tells you it's x comma 0. So 4 comma 0 is where that one crosses the x-axis. Now we're going to go over here and we're going to solve this one. It's also asking for the x-intercept. So y equals 0. I'm just going to cross it out because negative 3 times 0 is 0. It's nothing. So you are left with 4x equals 24. When the 4 and the x are right next to each other, they are multiplying. So to get rid of multiply, we divide. So x equals 6. And to write it as a point would be 6 comma 0. This is just one of those things that while it seems kind of easy and it ends up being a one-step equation, I find that it's something I forget about a lot. We get so in the habit of putting stuff into y equals. So it's just a really great, easy tool if we can remember it. So then our last examples are the y-intercept. So to find the y-intercept, naturally if the x-intercept is where y equals 0, the y-intercept is where x equals 0. So we're going to plug a 0 in for x and then solve for the y value. So I'm going to scroll down here and I have these two problems rewritten for y'all down here. And now I am solving for the y. So I want to get the y by itself. So I'm getting rid of the 3x because when I do 3 times 0, that gives me a 0. When the 6 and the y are right next to each other, they are multiplying. So to get rid of multiply, we divide. So y equals 2. And this is written as 0 comma 2 because a point is x comma y. And our last example on here is, again, we are solving for the y-intercept. So I need to get rid of the x. 4 times 0, because I'm going to plug in the 0. Okay, I'm plugging in the 0, so it's a little bit different of a get rid of that we're used to. When the negative 3 and the y are right next to each other, they're multiplying. So to get rid of multiply, we divide. And don't forget that negative, guys. That's y equals negative 8. So your point is 0 comma negative 8. And that is finding intercepts from the 4 different forms.